Today, we're diving into one of the biggest questions in tech. How do you take a website from just a single user to literally millions? We're going to walk through the entire journey based on the brilliant book System Design Interview by Alex Su. So let's get started. Right, so here's the big question that started it all. How on earth does a website or an app handle millions of people trying to use it at the exact same time? It really does seem kind of impossible, right? But it's not magic. It's a series of really smart engineering steps, and we're going to break them all down one by one. You know, every huge website you can think of, they all started somewhere. And that somewhere is almost always right here. A single, humble server doing absolutely everything. The web app, the database, the whole shebang. It's all living on one machine. For our little website, let's call it mysite.com, this is day one.
Okay, but that single server setup, it's not going to cut it for long if your site starts getting popular. And that brings us to the very first challenge, dealing with those early growing pains when traffic starts to pick up.
And here we have it, the first, most fundamental step to scaling up. You split things apart. You put your web server on one machine and your database on another. Think about it. They're no longer fighting over the same computer's power, it's CPU and memory. Now, each one can grow and be scaled totally on its own. It's a game changer. So when we talk about scaling, you basically got two choices. On the left, there's vertical scaling. That just means you keep making your one server bigger and beefier, more power, more memory. It's easy at first, but you eventually hit a wall. You can't just make one machine infinitely powerful. That's where horizontal scaling, on the right, comes in. Instead of one giant server, you add a bunch of normal-sized ones. For any site that's going to get massive, this is really the only path forward. All right, so we're adding more servers. But wait, this creates a brand new and pretty scary problem. What happens if one of those servers dies? Right now, if our main web server or our one database goes offline, the whole site is down. We've got to get rid of these single points of failure. So, what exactly is a single point of failure? Well, the official definition says it all. It's any single component that, if it breaks, takes the entire system down with it. It's the one domino that can topple the whole line. For a systems architect, this is public enemy number one. And this slide right here shows the solution perfectly. Look at the before on the left. One web server, one database. Each one is a huge risk. Now look at the after on the right. We've got multiple web servers tucked behind a load balancer, and our database has been duplicated or replicated. Let's look at what those two new pieces actually do. So the magic word here is redundancy. That new load balancer, it's like a traffic cop for the internet. It sees all the users coming in and directs them to whichever web server is least busy. If one server crashes, no problem. The load balancer just stops sending people there. Easy. Then for the database, we use replication. You have one master database that takes in all the new information, and it constantly copies everything to one or more slave databases. If the master ever fails, one of the slaves can be instantly promoted to take over. So now our site is strong and reliable, but with more and more users, it's probably getting pretty slow. So it's time to shift our focus to speed. And we're going to do that with two key tools, caching and something called a content delivery network. First up is the cache. The simplest way to think about a cache is that it's a super fast, short-term memory for your application. Its whole job is to remember the things that people ask for all the time so we don't have to bother the slow database for every single little request. And this diagram shows you exactly how that works. When a user asks for something, the web server checks the super fast cache first. If the data is there, we call that a cache hit. Boom, it sends it right back, super fast. If the data isn't there, okay, no problem. It goes to the database, gets it, and here's the important part, it saves a copy in the cache on its way back. So the next person who asks for it gets it instantly. This takes a massive load off the database. Our next speed boost comes from a content delivery network, or CDN. This is a special network just for our static stuff, things like images, videos, and code files that don't change very often. Basically, a CDN is a network of servers spread all over the world, whose only job is to get those files to your users as fast as physically possible. So let's see how it works. Imagine your main servers are in the US, but someone in Japan tries to load an image. Instead of that request traveling all the way across the ocean, it gets routed to a CDN server that's right there in Japan. The very first time, that Japanese server might have to fetch the image from the US. But after that, it keeps a copy. Now every other user in Japan gets that image almost instantly from the local server. And here's what our system looks like now. We've cleverly offloaded so much work. The CDN is handling all our images and videos, and the cache is handling a ton of our data requests. Our main servers are now free to focus on the really important, dynamic parts of the site. The system isn't just reliable anymore. It is way, way faster for our users. Okay, things are going great. Our site is so popular that we have users all around the world. So what's next? We have to go global, and this is going to require a huge architectural shift and thinking about data centers. All right, this next idea is absolutely crucial. We need to understand the difference between stateful and stateless. A stateful server remembers you. It keeps track of your session. That sounds good, but it's terrible for scaling, because now you're stuck talking to that one server. A stateless server, on the other hand, remembers nothing about you. Any server can handle any of your requests at any time, because all the info it needs is stored somewhere else, like in the database. This makes adding or removing servers an absolute breeze. And going stateless is what lets us do this: run our entire application in multiple data centers all over the world. But how do we get users to the right one? Well, with a clever trick called GeoDNS. It's a smart system that looks at where you are in the world and automatically sends your request to the data center that's closest to you. Someone in Paris gets sent to the European data center, someone in Singapore goes to the Asian one. The delay or latency is cut way down. We are so close to the finish line. To get to that final level of mind-boggling scale, we need to talk about the system's nervous system. We have to decouple our services so they can work and grow without even knowing about each other. And the main tool for that job is the message queue. Just think of it like a shared to-do list between different parts of our application. One part of the system, the producer, adds a task to the list. Then, whenever it has a free moment, another part of the system, the consumer, comes along, grabs the task, and gets to work. They never have to communicate directly. And this diagram is the perfect example. Let's say a user uploads a new photo. That photo needs to be resized, maybe have a filter applied. That's a lot of slow, heavy work. So instead of making the user sit there and wait, our web server, the producer, just drops a quick message into the queue that says, "Process this photo." And that's it. The user gets an instant response. Then, completely separately, our special photo processing servers, the consumers, are pulling jobs from that queue and doing all the hard work in the background. The two parts of the system can be scaled totally independently. And there we have it. Just look at how far we've come. We started with a single computer doing everything, and step by step, we've built it into a global, super resilient, high-performance system that can handle millions and millions of users. It's a pretty amazing transformation. So we've done it. We've scaled our little website from one server to a massive system ready for millions. But the journey of system design never really ends. So I'll leave you with this question. As our traffic just keeps growing and growing, what breaks next? What's the next bottleneck? Because trust me, there's always another one.